Hi everyone. Today we're going to be solving the HMMT 2019 Algebra and Test Problem 2. So the problem asks, compute the number of ordered pairs of integers ab with 2 less than or equal to ab, which are less than or equal to 2021 that satisfy the equation a to the power of log b of a to the negative 4 is equal to b to the log a of b times a to the negative third. Okay, so let's just try and simplify this a little bit. So let's just take the log of log base a of this whole equation and let's see what this will give us. So log base a will just cancel out this a and we'll just be left with log b of a to the negative 4 on this side. And then we can take this and then we have negative 4 log base b of a. Okay. And on the other side, we have log base a of b. And then we have this whole power which can be written just on the bottom, right next to this. So it'll be times log base a of b and then plus log base a of a to the negative 3 because this is just the product rule of logarithms. So we can just simplify this a little bit and we get log base a of b squared because that's the same thing, and then plus negative 3 log base a of b, so minus 3 log a base b. Okay, so now we can just transfer everything and let's just let x be equal to log a of b. And so just by reversing the bases, we know that log base b of a is equal to 1 over x. And let's just write this in quadratic form. So we have x squared minus 3x plus, because we have to transfer to the right-hand side, plus 4 over x is equal to 0. But then we can just multiply everything by x once again. So then we get x cubed minus 3x squared plus 4 is equal to 0. So now we can just solve for this thing by factoring using the rational root theorem. And if you do the rational root theorem out, you can just get the factors of 4 divided by 1, which is plus 1, plus or minus 1, plus or minus 2, and plus or minus 4. And then you can see that it all factors out to x minus 2 squared times x um, plus times x plus 1, which is equal to 0. And then we can put in our plugins back, so we get log base a of b minus 2 is equal to 0. So that means that log base a of b is equal to 2. That means that a squared is equal to b. And then we also have log base a of b is equal to negative 1. So that means that a to the negative 1 is equal to b as well. So we have to choose between one of these two. Well, it already said that 2 has to be less than or equal to a and b. So that means that it has to be positive integers only. So this is ruled out. And the upper limit is 2021. And therefore, we have to just find the number of AB ordered pairs such that a squared is equal to b. So we have to find an integer and then its square. So we can just take the floor function of the square root of 2021 and then subtract it from 1 because there would already be one pair of AB which is less than 2. So we have to exclude that. And then we just get the answer 43. So that is the answer to this problem. So it was a fun problem, and we used the rational root theorem from algebra, and we also used logarithmic functions and formulas. So thank you for watching, and have a nice day.